Hello everyone, welcome back to my channel Study with me. Today I'm going to explain another example of prediction questions for IB Chemistry Paper 2 standard level. It is not 100% guaranteed that this question will appear in the exam. Instead, you can treat these questions as a mock exam to check whether you are ready for the exam or to check what kind of topic that you're still struggling with. And these questions are following the IB exam style questions, so it is highly recommended for you to go over these questions. If you find this video is helpful, please don't forget to subscribe and let your other friend knows about my channel to support me. And let's get started. Lithium metal is known to react vigorously with water. Write a balanced equation for the reaction. So lithium metal, that would be solid, when it reacts with water liquid, will produce LeOH aqueous and hydrogen gas. So we need to balance them. So this will be 2, this will be 2, and this will be 2 as well. State the block of the periodic table where lithium is found. Lithium is found in the group 1, so it's S block. So group 1 and 2 is block, and start from 3 until 8 it's P, and then transition metal will be D block. If the resulting pH of the solution is 13.70, calculate the concentration of the lithium product formed in reaction A. So to calculate the concentration of lithium product form, so we can actually calculate the H plus first, because pH is known. So H plus will be 10 to the power negative pH, which is 10 to the power negative 13.70. So that would be 10 times to the power negative 14. So this is the concentration of H plus. And to find the lithium product, that would be LiOH. So this would be Li plus and then OH minus. So by finding the concentration of OH minus, we can actually find the concentration of LiOH. So now, as we know the concentration of H plus, we can find the concentration of OH minus. So Kw divided by concentration of H plus, you know the constant is 1 times 10 to the power negative 14. So divided by 2 times 10 to the power negative 14, which is 0.5 mole per decimeter cube. So this one also will be concentration of LiOH, because it has the same coefficient. So concentration of OH minus, it's the same with concentration of LiOH. So the concentration of LiOH is 0.5 mole per decimeter cube. If the volume of the solution is equal 1.5 decimeter cube, calculate the mass of solid Li required to reach a pH of 13.70. So now we need to find the mole of LiOH. So that would be C times V. C, we know it's 0.5 from this question. So 0.5 times V, it's 1.5. So that would be 0.75 mole. And mass would be N times mR. So that would be 0.75 times Li, which is 6.94. So that would be 5.21 gram Li. Why? We have the same amount of mole for Li and LiOH. Based on this equation, the mole of LiOH will be the same with the mole of Li, because it has the same coefficient. If an equivalent mass of lithium oxide was added to the same volume of water, calculate the new pH of the solution and whether this results in more or less H plus concentration in solution compared to pH 13.70 for Li in water. So when lithium oxide add or dissolve in water, it will produce lithium hydroxide. So now the mass of lithium it's the same with lithium oxide, because equivalent mass, right, to the same volume of water. So now we can find first mass of lithium oxide, which is 5.21 divided by its molecular mass, 29.88, which is 0.174 mole. So this is the same with the mole of, it should be times 2, because Li2O is 1, LiOH is 2, so times 2, that would be 0.348 mole of LiOH. Okay, so now we need to find the new concentration with this number of mole. So the mole is 0.348 divided by 1.5 decimeter cube, because it mentioned the same volume of water. So the volume of water is 1.5 decimeter cube, and you will get 0.232 mole per decimeter cube. So this would be OH minus, because LiOH. So LiOH, when it dissociates, will produce 1 OH. So the concentration of OH minus is 0.232 mole per decimeter cube. So now we can find concentration of H plus 1 times 10 to the power negative 14 divided by this concentration to find the pH through the concentration of H plus, which is 4.35 times 10 to the power negative 14. So the pH will be negative log 4.35 times 10 to the power negative 14. That would be 13.36. This is the new pH when you add the same amount of lithium oxide, which is 5.20 gram, to the same volume of water, which is 1.5 decimeter cube. Describe the bonding structure that exists in solid lithium. Lithium or cation lattice with delocalized electron. So metal exists as a lattice of cations where the unbound electrons are free to move throughout the lattice. Describe the bonding structure that exists in solid lithium oxide. It's ionic crystal lattice composed of Li plus ions and O2 minus ions. So lithium and oxygens are bonded ionically via electrostatic attraction between the opposite charges, forming a 3D lattice of alternating ions in the solid state. So it could be ionic crystal lattice composed of Li plus ions and O2 ions that is bonded ionically via electrostatic attraction. Copper 2 chloride can exist as an anhydrous solid or hydrate. A 1.78 gram of sample copper 2 chloride hydrate was heated on a watch glass until the blue solid changed completely to brown, and the following data was recorded. So only the watch glass 24.57, and by the mass of copper 2 chloride hydrate, which is that would be 26.35 gram, right? And then after 5 minutes heating, the mass becomes 26.03, so there is not much change of the mass. And then adding more 5 minutes becomes 25.99, and then add more 2 minutes becomes 25.99. So there is not much difference after heating 2 more minutes. So the question is, suggest a reason why the sample was heated for a second 5 minutes increment showing a mass change, because not all of the water removed in the first 5 minutes, because when heated, the water molecules that distributed throughout the lattice is released from the lattice steam if the time is not long enough, so some water still remained. Calculate the mass of anhydrous copper 2 chloride. Do not include the calculation of uncertainties in your work. So the CuCl2 mass is 25.99, and then the mass of watch glass is 24.57. So the mass of the copper chloride would be 25.99 minus 24.57. So it's 1.42 grams. So this without water. After water, all remove or evaporate. Calculate the mass of water in the hydrated copper 2 chloride sample. So H2O mass would be 1.78, right? Because this is hydrate. So 1.78 minus 1.42 gram anhydrous, which is 0.36 gram. Calculate the percent uncertainties on the mass of water in the copper 2 chloride sample. So we need to find the mass of CuCl2, which is 25.99. 0.01 minus 24.57, and with uncertainty 0.01, which is 1.42, and the uncertainties would be 0.02 because you will add these two. And now for water, that would be 1.78 plus minus 0.01 minus 1.42, 0.02. So that would be 0.36 gram plus minus 0.02. So percentage uncertainty will be 0.03 divided by 0.36 times 100, which is 87%. Determine the chemical formula for the copper 2 chloride hydrate from the experimental data. For NH2O would be 0.36 gram times 1 mole per 18.02 gram. Then we get 0.02 mole. And for CuCl2, that would be 1.42 times 1 mole divided by 134.45 gram, which is 0.011 mole. So NH2O divided by NCuCl2, which is 0.02 divided by 0.011, it's 2. So the chemical formula for the copper 2 chloride hydrate will be CuCl2 to H2O. State the chemical name of the copper 2 chloride hydrate from this experiment. The name is copper chloride dihydrate because it's 2. So 2, it's di. State the core electron configuration for copper with the electron number 29. So that would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. But this cannot be accepted because it should be full fill. So I will just use this short notation. So that should be 4s1, 3d10. So it should be full fill or half fill. In case you get 4s2, 3d4, this should be 4s1, 3d5. This half fill. The reaction of hydrochloric acid HCl with oxygen gas O2 exists in equilibrium according to the following equation. Deduce the express for the equilibrium constant Kc for the reaction of HCl with O2. So that would be the product to the power its coefficient divided by reactant to the power of the coefficient. The following quantities of the chemical species were added to a closed reaction vessels. Calculate the reaction quotient, which is Q. Q is calculated the same like Kc, but it includes concentration that might not reach equilibrium yet. So that would be So I would just plot the number. Yeah, it will be the same like this. So that would be 0.2 squared times 0.01 squared. Okay, and then 0.8 to the power 4 and 0.2, that would be 4.9 times 10 to the power -5. If the Kc of the reaction is 7.2 times 10 to the power -8, which is smaller than Q, deduce with a reaction if the reaction in B is at equilibrium, and if it's not equilibrium, which way it must shift to reach these states. It's obviously is not at the equilibrium because Q is not the same with Kc. Q is bigger than Kc. So Q bigger than Kc, where it causes products, concentration of product is bigger than reactant, causing the reaction shift to the reactant because concentration of product is bigger than reactant. So to minimize the change, it will shift to the left. So the reaction is not at equilibrium. The reaction of HCl with oxygen is exothermic. If the temperature is increased to 100 degrees Celsius, deduce which direction the equilibrium will shift and state the effect on the Kc value. So for HCl plus O2, let me just maybe do it here. So for HCl plus O2 produce 2H2O and 2Cl2, and the delta H is negative, which is exothermic. So this way forward will be exo because it's negative, and then this will be endothermic. Okay, so when the temperature increases, when the temperature increases, the reaction is endothermic as it absorbs the energy. Okay, so when the temperature increases, it will absorb the energy, right? So it is an endothermic. So the reaction will favor endothermic. It means the reaction shift left, the yield decreases, Kc decreases. So because favor endothermic, so it will shift to left and the yield will decrease because the reaction shift to left, and when the yield decrease, Kc will also decrease. Using section 11 of the data booklet, calculate the enthalpy change delta H for the reaction of HCl with O2 in kilojoule. So that will be average bond enthalpy. So this for HCl plus O2 to HOH, right? So that would be 4OH plus 2 ClCl. So 4 times 431 plus 498, 4 times 463 plus 2 times 242. This would be 2222. This would be 2336. So delta H would be 2222 minus 2336, which is negative 114 kilojoule. The reaction of HCl with O2 was performed experimentally with a measured enthalpy change equal to negative 125 kilojoule per mole. But the one that we just got is negative 114 kilojoule. So why the delta H value differ from those determined in E? Because bond enthalpy is calculation R average. Aluminum and copper can react in redox reactions. One common reaction is between aluminum metal and copper to nitrate. Write a Bellin equation for the reaction of aluminum with copper to nitrate, including state symbol. So aluminum solid, when it reacts with copper, NO3 2 copper nitrate, which is aqueous, will produce Cu and Al NO3 3 aqueous. This would be 2 and this would be 3 and this would be 2. The rate of this reaction can be measured using UV spectroscopy with the disappearance of the blue-green color of copper to nitrate when strips of solid ammonium are added to the solution. Calculate the instantaneous rate at 50 seconds in units of s to the power negative 1 using the experimental data showing a notation on the graph above. So when I do, okay, so that would be like this. Okay, so the rate at 50 seconds will be the slope at the tangent at 50 seconds. So that would be delta y per delta x, which is 0 minus 0.708. Okay, and then 117 minus, so this actually, because I cannot draw with the ruler, so this should be around here. Okay, should be around here, which is 117 minus 0, that would be negative 0.0061 s to the power negative 1. Suggest 2 changes to the experiment that would increase the reaction of rate. You can maybe increase the surface area because it's using strip. What strip? Strip of solid aluminum. And you can also increase the concentration of copper to nitrate, or you can also increase the temperature. If solid copper and solid aluminum were used to create a galvanic electrochemical cell, identify the following. So aluminum and copper, aluminum is more reactive, so this one will experience oxidation and this one will be reduction. Oxidation always happen at the anode and this always happen at the cathode reduction. So the anode material will be aluminum and then cathode will be copper. Half reaction at the anode. At the anode oxidation is lose electron, so Al 3 plus 3 electron. This one reduction for copper Cu2 plus 2 electron produce Cu metal. Identify the reducing and oxidizing agent in the aluminum and copper to nitrate. Reducing, it means oxidation. Oxidizing means reduction. So reducing agent is oxidation, which is aluminum, and then oxidizing agent is reduction, which is Cu2 plus. Nitrate ion can also react in redox reaction. An example of unbalanced half reaction for nitrate ion is NO3 minus produce NO2 minus. Deduce the oxidation state for this two. NO3 minus, so this negative 6 because negative 2 times 3 equal to negative 1, so N will be plus 5. NO2 minus, so this negative 4 because O, negative 2 times 2, and this should be equal to negative 1, so plus 3. Deduce the balanced half redox reaction. NO3 minus produce NO2 minus. we need to balance the number of oxygen. Here is 3, here is 2. So we can add by adding water. So we need one more O. So now O is 3, here is 3 as well. But H is not balanced, so we need to add for H plus right here. Sorry, 2H plus. Okay, so now the charge. Here is -1, -1, and we've got 2 more plus right here. So we can balance by adding 2 electrons. Organic reactions can transform one functional group into another. State the reagents required for molecule A to turn into molecule B. As you can see, there is OH right here. So the reagent, of course, will be water because it has OH and H. State the IUPAC name for molecule B. So 1, 2, 3. Alcohol at number 2. So propan 2 all. Molecule B is a member of an alcohol homologous series. State the molecular formula for the next member in the alcohol homologous series. For molecule B, it's C3H8O. For homologous series, you need to add CH2. So now it becomes C4H10O. Just add CH2. For the molecule identified in C, deduce with a reason if its boiling point is higher or lower than that of molecule B. Molecule C identified in C, C4H10O, has higher boiling point as it has stronger intermolecular force, which is London dispersion force. Okay, they both contain alcohol, right? C4H10O and C3H8O. So both contains hydrogen bond, both contain dipole-dipole force, and also London dispersion force. So to differentiate between these two, London dispersion force, that is depending on the higher number of molecular weight. So C4H10O has bigger mass or molecular weight compared to C3H8O. Therefore, London dispersion force in C4H10O is stronger compared to C3H8O because it has higher or bigger molecular weight. Molecule B is treated with an oxidizing agent, acidified potassium dichromate, and heat. Deduce the structure of the product molecule C that is formed. So this is secondary alcohol. When it is oxidized, will produce ketone. So that would be here, CH3, C double bond O, C, H3, which is propanol. If 2-methylpropanol, that would be COH, CH3, CH3, was treated with acidified potassium dichromate and heat, suggests a reason why there will be no reaction, because it is a tertiary alcohol. Because tertiary alcohol does not undergo oxidation reaction. Deduce the index of hydrogen deficiency for molecule A, B, and C. Molecule A, B, and C, the hydrogen deficiency, IHD. Okay, molecule A, it has double bond. Where is molecule A? It has double bond. Okay, so IHD will be 1. Molecule B doesn't have double bond, so it means IHD is 0. And for C, it has 1 double bond, so IHD will be 1. Because one double bond between any atoms will give IHD 1. The below infrared IR spectrum was obtained for one of molecules A, B, C. A, B, or C. Using section 26 of the data booklet, deduce with a reason which molecule produced the IR spectrum below. So there is 1700 to 1750, which is C double bond O. So that would be molecule C, SC double bond O, present at 1700 to 1750 centimeter to the power -1, which is ketone. For one HNMR spectrum of molecule B, state the number of chemical signal that would be present. So molecule B, it's CH3, CHOH, and CH3. So this and this will be the same, and this B and this C. That would be 3 signals. That's all for the explanation for another examples of reduction paper for IB Chemistry Standard Level Paper 2. If you find this video is helpful, please again don't forget to subscribe to my channel and let your other friend knows about my channel to support me. Thank you for watching, and bye.